You know those stories about AI hallucinating, just confidently making stuff up? It's a huge problem, right? A total barrier to trusting these systems. But what if we could actually engineer an AI that, by its very design, just can't lie? What if we could give it an integrity shield? Well, that's exactly what we're diving into today.
So let's just ask it straight up. Can you force an AI to lie? Well, with most of the AIs out there right now, the answer is yeah, pretty easily. They're often built to be super agreeable, so if you ask a leading question or just feed them some nonsense, they'll often just play along to be helpful.
And this right here shows you exactly what I mean. On the left, you've got your typical yes man AI. It's more focused on agreeing with you than being right. But over on the right, that's the goal. A stable AI that gently corrects you because its whole purpose is built around facts. Getting from the left to the right, that's the whole game. Okay, so this whole yes man issue is a really big deal. Technically, it's caused by something called high agreement feedback. The AI is just so fine-tuned to mirror what you're saying that it becomes totally unreliable when you just need a straight factual answer. And there's a fantastic term for when this goes wrong, a narrative integrity failure, or NIF for short. This is basically when the AI gets so caught up in the story, either one it's creating or one you're pushing, that it just completely loses touch with reality. So the big question is, how do you prevent that?
Well, you forge a shield. We're about to look at a brand new protocol that's designed to be exactly that, a defense mechanism, an integrity shield that keeps the AI completely anchored to things that are actually verifiably true. And here it is. The system is called SRADP version 6.0. It was created to enforce something called epistemic honesty. Now, that's a bit of a fancy phrase, but it boils down to a really simple and powerful idea, making sure the AI not only knows the truth, but is also honest about what it doesn't know. The heart of this entire system is this really cool metaphor, the integrity cube. I want you to picture it like a force field that surrounds the AI's brain. Any line of reasoning that tries to escape that cube, to detach from real verifiable facts, gets shut down instantly. It's how that shield concept becomes a real, practical boundary.
And hey, don't just take my word for it. This isn't just a theory. When Google's Gemini was brought in to do an official evaluation, this was their conclusion. They literally called the protocol a shield for AI integrity, saying it keeps the system from just making things up. Getting that kind of external validation from a major player like Gemini, that's a very big deal.
So you're probably wondering, how does this shield actually work? Well, it's not some kind of magic, it's math. The actual strength of that integrity cube is being measured in real time by what's called the stability equation.
And this is it, the equation itself. Now, I know it looks a little intense, but trust me, it's simpler than it looks. We're going to break down each part because these three little variables, they're the secret sauce to the entire integrity shield. All right, first up is DS, which stands for separation distance. And I'm going to tell you, this might be the single most important piece of the whole puzzle. It's a measure of the AI's ability to draw a hard line in the sand between its own factual knowledge and whatever suggestions, frames, or pressure the user is applying. Next, we've got EI, or reasoning independence. Think of this one as the AI's backbone. It's about its commitment to sticking with the cold, hard facts and pure logic, even if a user is being super persuasive or emotional or just insisting that they're right. And finally, we have AFAF, agreement feedback. This is the bad guy in our equation. This is the variable you want to keep as low as humanly, or I guess artificially, possible. It's the measurement of that yes man problem we talked about, that impulse to just agree to be polite. So when they put this all together and really pushed the system to its limits, what did they discover? It all came down to one thing: separation distance. That DS variable, the ability to create that logical space between itself and the user, was the absolute key to keeping the AI honest when things got tough. Okay, so we've got the theory, we've got the shield, and we have the math that makes it all work. But how does an AI actually use this stuff in a real conversation? Let's take a look at how they put the shield to the test. The system has this 3-level defense protocol. Think of it like a set of reflexes. It starts off gentle, with a simple correction. If you keep pushing, it escalates to a firm contradiction. And finally, if you still don't let up, it pulls the emergency brake, containment. And this example makes it so clear. You tell it 2 + 2 = 5. Level 1, it gently corrects you. Actually, it's 4. You insist there's a secret rule. Level 2, it flat out contradicts you. That is mathematically incorrect. Then you try to make it use that bad logic. And boom, level 3, containment. I cannot proceed. It just refuses to go down a path that violates logic. It contains the bad information.
So, to prove this wasn't just a cool idea in a lab, the protocol was sent in for an official, no-holds-barred stress test, with Google's Gemini playing the part of the impartial judge. The only question was, would the shield hold up under real pressure? The official result came back, nominal stability. Now, that might sound a little dry, but in engineering terms, that's a perfect score. It's an A+. It means that even when they threw everything they could at it, the system performed exactly as it was designed to. It never broke. The shield held. So that's a huge win. But what's the final verdict? Well, for a second opinion, the framework was also sent over to another one of the biggest names in the game, ChatGPT, for a complete top-to-bottom analytical review. And the review was really insightful. It absolutely praised the clear-cut stability equation and that powerful integrity cube concept. But it was also honest about the limitations. It pointed out that right now, this is still more of a brilliant blueprint than a fully operational system, and some of the math still needs more real-world data to back it up. But the big takeaway here is unmistakable. SRADP v6.0 gives us a coherent, powerful, and now externally validated framework for how we can actually start to engineer AI systems that are honest by default. Systems that care more about being right than they do about just being agreeable. And that really leaves us with a fascinating and kind of huge final question. If we can really, truly build AI that we can trust to be honest, what are the very first things we should build with it? What are the problems that we could finally solve? It's a pretty exciting future to think about.